Chapter 14, conic sections. Section 14.1, circles. So, a circle is the locus of all points equidistant from a fixed point, called the center of your circle. And that fixed distance we'll call the radius of our circle. Suppose that we do this relative to some coordinate system. And so suppose that we'll have a circle centered at the origin. And so I have a circle here. And so I have the locus of all points equidistant from a fixed point, called the center of my circle. And I will put the center of my circle relative to this coordinate system at the origin of this coordinate system. And so let's determine the equation of my circle. Suppose that the radius here is r, then by Pythagorean's theorem, I have that x squared plus y squared equals r squared. And so let me suppose that we have a circle centered at at some other point. So a circle centered at the point HK. And so, again, suppose we have a circle of radius r centered at the point HK, and this is relative to some coordinate system. Then we'll just translate x and y, and so we get x minus h squared plus y minus k squared equals r squared. And so that is the equation of a circle centered at hk of radius r. And this is the equation of a circle centered at the origin of radius r. Let's do some examples. Let's say on page 581. Let's do problem number 4. In exercises 1 through 16, find an equation that describes the circle satisfying the given conditions. The center is at negative 1, 8, and the radius is 7. Therefore, let's use the equation of a circle centered at HK of radius r. And so I have here that h and k are negative 1 and 8, and so I have x minus a negative 1 squared plus y minus k, 8 squared equals r squared. 7 squared is 49. And that is the equation for a circle centered at negative 1, 8 of radius 7. Let me do problem number 11. The center is at 5, negative 7, and it passes through 2, negative 3. Okay, so I have that the equation of a circle centered at hk of radius r is the following. And so, by the fact that this is hk, I have x minus h5 squared plus y minus k, negative y minus a negative 7, y plus 7 squared equals r squared. Now let's just plug in for x and y. Well, a point. Well, we have a point. It goes through the point 2, negative 3. And so I have here 2 minus 5 squared plus negative 3 plus 7 squared equals r squared. And so r squared is equal to 2 minus 5, negative 3 squared, plus 7 minus 3, 4 squared. And so 9 plus 16 is 25. Therefore, I have that x minus h squared plus y minus k squared is r squared. And that is your answer. Let me do problem number 16. The diameter has endpoints 1, 4, and negative 1, negative 2. And so, actually I should say that if I go from one end of a circle to the other end of a circle, and I pass through the center, then this is called the diameter of a circle. And so, recall that the midpoint of a circle, midpoint of a line between 2 points is just the average of the x coordinates, the average of the y coordinates. And so, note that the midpoint between 2 points on the diameter will just be the center. And so, I have here the midpoint, which turns out to be the center, is just x1 plus x2 over 2, y1 plus y2 over 2. And so 0 divided by 2, 2 divided by 2. Therefore, the center is at the point 0, 1. Let's determine the equation of my circle. So x minus h squared plus y minus k squared equals r squared. We have that the center is at, is at 0, 1. Let's determine r. And so I guess I will use for x 1, for y 4, and let's determine r. So r squared equals 1 squared plus 3 squared. 1 plus 9 is 10. Therefore, the equation of my circle is just x minus 0 squared. Actually, I'll just call x minus 0 x. So it's x squared plus y minus 1 squared equals r squared, 10. And that is the equation of my circle. Let me do problem number 18. In exercises 17 through 38, verify that the equation describes a circle, and then find the center and radius of the circle. Well, I have here x squared plus y squared equals r squared. Therefore, the center of my circle is at the origin, and the radius of my circle is just the square root of 5. Let me do problem number 24. And so I have x squared plus y plus 7 squared equals r squared. And so the center of my circle is, well, the x-coordinate of the center is going to be 0. The y-coordinate will be, well, the opposite of positive 7 is negative 7. And the radius, well, the square root of 9 is 3. Let me do problem number 32. X squared plus y squared minus 2x minus 4y is equal to 11. And so let's try to put this into proper form. And so I'm going to complete the square. So let me group all my x's and all of my y's together. And so let me complete the square. So I have here, since there's a 1 in front of the x squared, then to complete the square, I'll just take negative 2 divided by 2, which is negative 1, squared 1. Add that to both sides of my equation. Negative, and since there's 1 in front of the y squared, negative 4 divided by 2 is a negative 2 squared is 4. And I add 4 to both sides of my equation. And so this is a perfect square trinomial, x minus 1 squared. Perfect square trinomial, y minus 2 squared equals 11 plus 2 plus 1 plus 4, 16. Therefore, the center of my circle is at 1, 2, and the radius, square root of 16, is 4. Let me do problem number 28. 2 x squared plus 2 y squared minus x minus y equals 11. Let me group x's together, y's together. Okay, so let me complete the square. So negative 1 divided by 2 times 2 it's going to be 4. Uh, -1 divided by 2 times 2, which is 4, is a -1/4. Squared is 1/16 times 2 is 1/8. So let's add 1/8 to both sides of my equation. -1 divided by 2 times 2, -1/4. Squared is 1/16 times 2, 1/8. So let's add 1/8 to both sides of my equation. And so I get 2 times x minus 1/4 squared plus 2 times y minus 1/4 squared, due to the fact that these are perfect square trinomials, is equal to, well, let's see. Let me get a common denominator, multiply and divide by 8. So 8 times 11, 88, plus 1 plus 1, 90 over 8. Divide both sides of my equation by 2. And so I get divided by 2 the same as multiplying by a half. And so I get x minus 1/4 squared plus y minus 1/4 squared is equal to 90 divided by 2 is 45 over 8. Therefore, the center of my circle is at 1/4. The radius of my circle is going to be, oh, actually, I should leave it as 90 over 16. And so the radius will be the square root of 90 over 16. So the square root of 90 over the square root of 16. I can write 90 as 9 times 10. Square root of 16 is 4. Square root of 9 is 3. We're at 10 over 4. And that is the radius of your circle. Let me do problem number 28. That was 38. That was problem 38. Let me do problem number 40. Find the linear equation whose graph line is tangent to the circle. X squared plus y squared equals 4. And this will be at 0, 2. So notice that, well, what is a tangent? So if you happen to have a circle and you happen to have a line that just touches that circle at this one point, then this will be its tangent line. Okay, matter of fact, we can sort of just rotate this so it'll look a little nicer. Suppose I have a circle and I've rotated it, so now it intersects right there. So I can see by this that actually if I look at a diameter of my circle, then this diameter actually intersects this tangent line well, They intersect so that these two lines are perpendicular. So the tangent line here is perpendicular to the diameter. So that means that if I had any sort of circle and I looked at its diameter, then these two, the diameter and the tangent line, would be perpendicular to each other. Okay, so let's see this. Well, notice that in this case, I have that we have a circle of radius 2 centered at the origin. And so I want to find the equation of a tangent line passing through 0, 2. Well, the equation of the tangent line is just y equal 2. It's just that horizontal line. Let me look at problem number 42. So not a completely trivial. So problem number 42. Find the equation of the line touching the circle, x squared plus y squared minus 4x plus 6y equals 45. And this is, I want to find the equation of the line tangent at negative 1, 4. Okay, so first let me determine the radius and center of my circle. And so let me group all my x's together. Let me group all my y's together. And then I'll complete the square. Negative 4, since there's a 1 in front of the x squared, negative 4 divided by 2 is the negative 2 squared is 4. Oops. So let's add 4 to both sides of my equation. Since there's a 1 in front of the y squared, 6 divided by 2 is 3. 3 squared is 9, so let's add 9 to both sides of my equation. And so I have here each of these in parentheses are perfect square trinomials. So x minus 2 squared plus y plus 3 squared is equal to 50, 7, 58. And so the center of my circle is at 2, negative 3, and the radius is radical 58. Next, well, I have here the center of the circle, so that's good. And I have a point on the circle, and so that's going through that point and through that center will be the diameter. So let's figure out the slope of that diameter. And so to figure out the slope of the diameter, let me just do y2 minus y1 over x2 minus x1. And so I'll just use the point 4 minus a negative 3 over negative 1 minus 2. So you get 7 over negative 3. Well, I want to find the slope of a line perpendicular to this diameter. And so I'll take the negative reciprocal. And so now let's try to find the equation of a line passing through negative 1, 4, having slope 3 over 7. And so I have, by the point slope form for the equation of a line, y minus y1 equal m x minus x1. And so y minus, well, y1, 4, equals m, 3 over 7, x minus x1, x minus a negative 1, x plus 1. And that is the equation of your tangent line. So that finishes off section 14.1.